Dear students, so today I am going to explain the invariance of Newton's second law. So what is Newton's second law? According to the Newton's second law, the rate of change of momentum in a body is proportional to the external force acting on the body. So that is equals to F is equals to ma, that equals to dp by dt. So that is gives the Newton's second law. So in this concept, I am going to show the Newton's second law is invariant. Invariant is nothing but unchanged in two frames of reference. One frame is fixed and another frame is moving with constant velocity. So in both the frames, the Newton's laws are applicable or constant. Invariance, they are not changing. So that is going to be proved in this case. If that second frame is moving with constant velocity, it is not accelerated. So to prove that, first I am imagining a vehicle. For example, you are standing at in front of bus stop. So one vehicle is moving away from you. So you can imagine one frame of reference. So that means you are the observer where you are standing. That position is called the observation position origin for fixed frame of reference. From your side, if the vehicle is moving, so we imagining a frame of reference attached to that vehicle. So in that, with respect to that moving vehicle, I am observing an event. And with respect to this fixed frame of reference also, I am observing an event. So the event is nothing but which is described by position and time. So that is indicates the event. So position only. Position in the sense, suppose you are seeing one object here. Then what is the position of that object? And at which instant of time you are observing that object? So that is indicates event is occurring at that instant. That is with respect to this origin and with respect to this origin. Okay. And they are represented by this form. And here the vehicle is moving. Vehicle is nothing but the frame of reference which is attached to that vehicle is also moving with velocity, constant velocity v. Therefore, the distance traveled in a time of t is vt. We can write like this. Okay. And this is the position vector which joins the event with respect to the fixed frame of reference. And this is the position vector which joins the event with respect to the moving frame of reference. Then this is the distance traveled by the vehicle or frame of reference which is moving from initial position to after time t, it travel a distance of vt. Then according to the vector addition formula, we can write this r vector is the resultant is equals to the sum of these two vectors. And rearranging that equation, you will get this form. And differentiating the above equation with respect to t, we will get the velocity, that is dr prime by dt is equals to dr by dt minus v is constant because the velocity of the moving frame is constant. Then dt by dt is equals to 1. And again differentiating this equation, you will get this form. But the differentiation of this velocity, constant velocity is equals to 0 because it is a constant. The velocity is not changing. So that's why the dv by dt is equals to 0. Then we can write this d square r prime by dt square is nothing but that is the rate of change of velocity is called the acceleration. And this is also acceleration. So this is the acceleration with respect to the moving frame of reference, and this is the acceleration with respect to the fixed frame of reference. So that means if you see from any frame of reference which is fixed and another frame which is moving with constant velocity, the acceleration is same with respect to the both the frames of reference. If the second frame is moving with constant velocity, then we can write the force experienced by the object here will be written as ma prime is equals to ma, that is equals to a. So this is the invariance of Newton's second law in these two frames of references. And we can write the equation, this equation as r prime is equals to r minus vt, and their respective position coordinate can be written as x prime I plus y prime j plus z prime k. It is a vector. This is represented in terms of their components, and r is equals to xi plus yj plus zk minus vt. So here the velocity is only along x direction. That's why we are taking only I component of this distance. Velocity is acting along x direction only. V into t into I. This is the displacement along x direction. And if you take the common, I is common, that is along x direction, we have the displacement x and velocity into time is also displacement along x direction. Then we can write x minus vt into I plus yj plus zk. Therefore, x prime is equals to x minus vt, y prime is equals to y, z prime is equals to z. And instant of time is observing from both the frames is same, that is t prime is equals to t. Then these equations are called the Galilean transformation equations. Galilean transformation equations. Okay. Thank you.